Hello, this is another video tutorial on how to use PHSTAT for chi-square test of independence. Chi-square test of independence is a statistical test that is used to determine if there is a significant relationship between two variables where the two variables are measured in either in the nominal level or in the ordinal level. Now let's consider the question, is gender related to smoking status? Now using our data under the gender column and then the data for the smoking status. The two variables are gender and smoking status. So variable 1 is gender, and gender is a qualitative or a categorical variable which is measured in the nominal level. In our data here, there are two categories that we use: male and female for the gender, or male participants and female participants. The second variable is the smoking status. The smoking status is also a categorical variable, and there are three categories in the data under smoking status: 0, 1, and 2. The code 0 represents participants who do not smoke. 1 are participants who smoke less than 1 pack per day, and 2 are participants who smoke 1 or more than 1 pack per day. So we start with a null hypothesis that the gender is not related to smoking status, or it can also be stated as there is no significant relationship between gender and smoking status. The alternative hypothesis is gender is related to smoking status, or there is a significant relationship between gender and smoking status. We will use 0.05 level of significance. Now, after stating the null and the alternative hypothesis, we will construct the contingency table, because in chi-square you have to construct first the contingencies table. So go to add-ins, PHSTAT, then descriptive statistics, and then two-way tables. Click row variable cell range, or click gender for the variable cell range up to the last data under gender, and for the column variable cell range, click smoking status up to, or highlight the values up to the last value under the column smoking status. Then click OK. So this is now the contingency table. It is a 2x3 contingency table, meaning there are 2 rows and there are 3 columns. 2 rows represents the 2 groups for gender, and 3 columns represents the 3 groups or 3 categories for smoking status. Now we are going to run the chi-square test of independence. Go to add-ins, choose PHSTAT, and then go to multiple sample test and choose chi-square test of independence. The level of significance is 0.05. So use 0.05. Number of rows is 2. Number of columns is 3. Then click OK. So we have an empty contingency table. So we must transfer our values from, go back to the two-way table sheet and copy the values in the contingency table. Paste the value in the chi-square table. So paste value. So the first table is the table for observed frequencies, and the second table is the table for expected frequencies. So here, it implies that there are 27 female who do not smoke. There are 22 male who do not smoke. A total of 47 participants who are not smoking. Now, in the second column represents participants who smokes less than 1 pack per day. There are 37. 18 are female, 19 are male. And then in the third column, which are participants who smokes one or more than one pack per day, there are 16 participants, 7 are female, 9 are male. There are 50 female participants, 50 male, and a total of 100 participants. The second table is the table for expected frequencies. To compute for the expected frequencies, it is equal to the row total times the column total divided by the total sample size. For example, the expected frequency in this cell is derived from the column total, which is 47. The cell where 23.5 is found, so it's in the column where 23.5 is found, that is 47 times 50 divided by 100. So divided by 100, that's 23.5. 18.5 is computed from 37 times 50 divided by 100. 8 is computed from 16 times 50 divided by 100. So 8 is again computed from 16 times 50 divided by 100. Thus, these are the values for the expected frequency for each cell. However, the chi-square test of independence could not be used if there is an expected frequency in the cell that is less than 5. That is one of the requirements for the chi-square test of independence. So if we observe each cell, there is no expected frequency that is less than 5. Thus, there is a note here that expected frequency assumption is met. Because if there is an expected frequency less than 5, the note will be expected frequency assumption is not met. So if that would be the case, you have to increase the sample size so that there will be no cells with less than 5 expected frequency. Now, the chi-square test statistics is 0.468516 or 0.47, which is equal to the summation of the square of the difference between observed and expected over expected frequency. It's equal to point. So this is 0.47 is equal to the sum of these values. And the critical value is taken from the chi-square critical value table. Chi-square test of independence is a right-tailed test. It does not have a left-tailed test or a two-tailed test. And the critical value would depend on the degrees of freedom. The degrees of freedom is 2, which is equal to the product of the number of rows minus 1 times the number of columns minus 1. 2 minus 1 times 3 minus 1. So 1 times 2 is equal to 2. Since the chi-square is less than the critical value, thus the decision of the test is not to reject the null hypothesis. Or looking at the p-value, which is 0.79, which is greater than 0.05, which is the level of significance, again, the decision is to reject the null hypothesis. Thus, the conclusion is that gender is not related to smoking status, or there is no significant relationship between gender and smoking status. Now, if the test tells that there is a significant relationship between gender and smoking status, so for example, p-value is less than 0.05, then you have to describe the strength of the relationship, either weak, moderate, or strong, by computing for the Kramer's V. The Kramer's V is used to describe the strength of the relationship if the chi-square test of independence shows that the relationship is significant, which is equal to the square root of the quotient of the chi-square value and divided by n times the smaller value between the number of rows and the number of columns minus 1. However, in our example here, since the relationship is not significant, there is no need for us to compute for the Kramer's B. So, this ends my tutorial for chi-square test of independence. Thank you very much.